Okay, this is going to be the beginning of video number 2. So hopefully you guys watched video number 1 yesterday, or maybe you're really lucky and you're watching them all in a row because you procrastinated. But we're going to continue on with extracting minerals. And so this is basically a review. As I said in the last video, the main way that we extract them is by surface mining and subsurface mining. So the process of mining, we're going to be able to get down into the ground after we find the minerals and remove the ore. And again, just to remind you, the ore is a rock that contains a percentage of a certain mineral. So surface mining, it says here it's more common because it's less expensive. If you think back to the chapter for coal, we said that 60% of the mines in the United States are surface mines. And so it's cheaper to mine. The mineral tends to have to be within 100 meters of the surface in order to get it so that you don't have to subsurface mine. It tends to be safer for miners than subsurface mining. And we would obviously prefer to surface mine, but sometimes minerals are too deep and we actually have to do subsurface mining. And so 2 examples here of surface mines is open pit and strip mining, and we're going to look at pictures of those on the next slide. Subsurface mining, again, as the name states, you have to go below the surface. Tends to be much dangerous for miners. So the risk of death due to an explosion. So many times there are pockets of methane down into the mine, and so if there is any type of like spark or ignition, it can cause a massive explosion. So we would prefer to surface mine. 2 examples of subsurface mining would be a shaft mine and a slope mine. Okay, so let's look at some surface mines. The picture you see right here, this is a open pit mine, as it says on the top of the slide. An open pit mine is just a hole, a huge hole that is basically made in the center of the mine here. The hole itself is called a quarry. And many times we're able to extract iron, copper, stone, and gravel from these open pit mines. So you can kind of see some of the trucks maybe in the center of the mine. And we're basically removing the ore and we're going to take it to be processed. So if you look closely again at this picture, you can see some of these tiny little cars in this large open pit mine. So an open pit mine is just mainly a large hole in the ground. Strip mining, this is another type of surface mining, and I think I explained this to you in class, but basically with strip mining we're going to mine in strips, and we are going to remove something called the overburden. And you need to know what overburden and what a spoil bank is. It doesn't define it on here, but you can see the words there. You have overburden on the right, spoil bank on the left, and then you see the ore on the bottom. So with strip mining, we're going to remove the overburden. The overburden is just the overlaying layers of soil and rock, and it must be removed first with the vegetation in order to get to the ore. So underneath the overburden is where we're trying to get to, and that's where the ore is located. So you can see, think about your soil layers and the different characteristics of soil that we talked about. So all of those soil organisms, and as you get deeper, we're going to have our lower layers. So we're basically removing the overburden. This is the overlaying soil and rock that has to be removed to get to the ore. The spoil bank is a hill of loose rock. So you can see here this power shovel, it is taking the overburden and putting it into a spoil bank. And on the left side you see this hill of loose rock. And so this is a spoil bank. And that's basically the difference. We're removing the overburden and putting it into a spoil bank. And so with strip mining, you're basically going to mine in parallel trenches, strip by strip, and the overburden is going to go into the old trench. So as you mine in like rows or strips, whatever you have, all of that overburden is going to be taken out and put into the previous trench that you just mined for that mineral. So it says strip mining removes overburden along with narrow strips to reach the ore beneath. And so this again is an example of surface mining. And before we move to subsurface mining, just to have you think back to the environmental problems associated with surface mining, as you can see, we're removing all the natural vegetation, so we're going to increase erosion. And we can also look at in a second some more acid mine drainage information. So surface mining, we have open pit and strip mines. Moving on to subsurface mines. So this is showing you a picture of the shaft mine. With our subsurface mines, we're not removing the overburden. So you can see the shaft mine. It's basically giving us a shaft that's going to go directly down into the ground. Notice that the overburden stays intact here. And we have an air shaft and a main shaft. So basically we have a vertical shaft. Ore is broken up underneath the ground and it's hoisted up through these shaft buckets. A series of explosions are used in order to get to the mineral that we're trying to extract. So it says on the slide, in a shaft mine, a hole is dug straight through the overburden to the ore, which is removed through shaft buckets. And then all of those buckets are brought up to the surface, and then they're going to be processed, which we're going to talk about in a second. So this is a shaft mine. It contains shafts. A slope mine, another example of subsurface mining, is when we have a vertical shaft. So it also has what's considered a shaft, but you can see this vertical shaft here, and so instead of having to hoist like the ore up in buckets, we could use carts, we could use cars, any type of system that's going to be able to bring it up to the surface. So many times this is done in the side of a mountain. It says in a slope mine, an entry to the ore is dug at an angle so that the ore can be hauled out in carts. And so that is the second example of a subsurface mine. If we are subsurface mining, we have to pump water as well as surface mining, pump water out of the area because obviously there's going to be a point when you hit the groundwater. So we use what's called a sump pump. So sump pump, and it's going to pump out the water, keeping it dry. Okay, so some environmental impacts of mining. So let's look at what we have here. First off, as I just mentioned a second ago, especially with surface mining, anytime you're going to remove the vegetation, the natural vegetation that's holding the soil in place, all the root systems that are holding the soil in place, we're removing it all. Anytime you're going to do that, you're going to make the land prone to erosion. So erosion, your first one. Another negative impact of mining is the amount of water that is used. So must pump, like I said, a sump pump is going to pump water out of the mine to keep it dry. We're going to hit the water table at some point. You obviously can't effectively mine when you have water infiltrating into the mine. So we're going to usually drop the water table. It actually drops the water table in nearby areas, and sometimes it causes the springs to dry up, so that's also a problem because we're just taking all that water and we're just pumping it out. Many farmers who farm in areas where we tend to have mines, they're very concerned because obviously they use the water for irrigation, and we said that 70% of our water use in the world goes towards irrigating crops. So we need that fresh water. We already talked about shortages of fresh water, so we're basically pumping it out and just wasting it. And most environmentalists, all environmentalists, would like to see mining companies inject that water back into the ground. So it's not something that always happens. Sounds like obviously a bright idea, but these things are very expensive. So to remove the water just to make it dry and to make a profit, obviously they want to make a profit off of these minerals. It can be expensive. So for the most part, they just pump the water out and they're just like wasting fresh water. And then the third one, which we've talked about so many times, acid mine drainage. Don't forget, you may see this abbreviated as AMD. Gives you the definition here. I know I mentioned it on the first slide. Pollution caused when sulfuric acid and dissolved lead, arsenic, or cadmium wash out of mines into nearby waterways. So I guess you can note from this definition, I know I say sulfur, 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 but it also has some other heavy metals that can dissolve in the water. So heavy metals we know are harmful to us and aquatic organisms. Many times it's going to wash away into waterways, can enter down into the ground, and when it rains heavily, so if you have a major rainstorm, it's going to cause more of this acidic liquid to kind of make its way into our waterways. So not something that we want to be drinking, not something that we want to be fishing from. Okay, and so there's a little case in point, I believe. You can kind of see the picture here of the Berkeley Pit. If you look at that hole in the ground in the picture, this is a open pit mine in Montana, actually closed in 1982. It started operating in 1955, and it was purposely used to mine for copper. And it is now this big hole in the ground in Montana. You can kind of see it right here. If you were interested in going to visit this site, you could pay $2 and stand on the ledge and kind of look in the Berkeley Pit. So it's a big hole in the ground. It's estimated that the hole is about 1,600 feet deep, and it is filling with toxic water that has a pH of about 2 to 2.5, and all of that water contains some of the heavy metals we just talked about, lead and arsenic. It is a Superfund site. I know I mentioned that before, but the Superfund Act is a fund actually, that is going to clean up old hazardous waste sites throughout the United States. So it's the largest Superfund site in the United States. Again, taxpayers' dollars goes to cleaning this up because the company that mined this area didn't. And generally, when a mine closes, you've been pumping the water out for some period of time, all the pumps are turned off, and so the water starts to fill into the ground here. So think about all the precipitation and all the rain that is filling up this hole, and you probably think, who cares? What's the worst thing? The water is going to reach the top of the hole and then what, spew out? Well, a major issue here, and if you look at this picture, is that there are concerns that all of this acidic water, you can kind of see in this hole here, is that it's going to increase. So it's increasing right now about a foot a month. It's going to increase the water to the water table. So as the water increases, it's going to eventually infiltrate into the groundwater, and obviously people use this water for drinking and for irrigation. And so then you cannot use the water anymore if that happens. So it's estimated that by 2020 the groundwater will reach the pit level, and there's going to be so many dissolved metals in it, heavy metals and pollutants, and we're not going to be able to use the water. So really they need to look into a treatment plant, and that is in the works of constructing one, and hopefully use some new techniques that we're going to talk about in a second in order to kind of clean up this area. But this is just an example of what can happen when we have an old mine that has not been reclaimed or been fixed to its natural state. Okay, if you look at this, this shows you, this is from your textbook from 16.2. You can see the ore and the waste production for selected minerals here. Look at that gold right there. Look at the percentage of that rock or ore that becomes waste during the refining process. So we have a lot of waste. I think we're getting that mineral, and the value of gold is pretty high, especially for copper. You can see that 99%. And we're removing all of that excess rock, and we're just trying to get that mineral. So what do we do with all of that rock? Well, this is what we do. If you look at this picture right here, it shows you, and you can kind of scale with, like, for size, how big these mounds are. We basically take all of that excess rock that's associated with the mineral, and we put it in these large heaping piles outside processing plants. And this stuff right here is called tailings. So this is another important vocab word. So this giant pile of waste near a processing plant, this is known as tailings, and it's all of that waste rock that has been removed in the refining process. And so this is actually a picture in Idaho, and like I said, the truck kind of gives you a scale. So it says here 80% or more of mined ore consists of impurities, and all of these impurities are called tailings. And many times these tailings can contain toxic materials, cyanide, mercury, sulfur. Problems with these tailings, you can imagine environmental problems. It can contaminate the air. It can run off into waterways. It can leach into nearby rivers and kill fish. So we basically have no place to put all of these tailings. And so it ends up being just placed right outside this cool processing plant. We talked about smelting a second ago. Smelting is the process by which we remove the mineral from the slag. So we're going to have some slag associated with smelting. And not only that, but anytime you're going to heat up something, you're going to release or burn something, we're going to release some carbon dioxide, which you know is a greenhouse gas. Because these rocks contain sulfur, it's just like burning coal. These rocks are going to contain sulfur. Air pollution control devices need to be used to reduce the sulfur. As we've said, sulfur contributes to acid rain and acid deposition. So we need to use some air pollution control devices such as a scrubber. We can burn it along with limestone. So we said limestone helps to settle out the sulfur. If we want to remove the particulate matter, we also talked about electrostatic precipitators. Don't forget, so that's something that we put in the smokestacks that help to remove the fine little particles of the particulate matter. Oh, and smelting requires a lot of energy. So that's another problem. Obviously we know fossil fuels are non-renewable. And as I showed you in the smelting process, we're going to use a modified form of coal many times called coke. So it's going to require a lot of energy, a lot of fossil fuels for the combustion process. Okay. And I will save the rest for your next video.